All right, so I'm going to spend the next 20 minutes talking about something that I've been really passionate about for a number of years, which is documenting and using patterns to help us when we're building out our data and our analytics platforms. And the reason I do this is it'd be fair to say that when it comes to data and analytics, everybody has an opinion. We had opinions between Inman and Kimball many years ago. When OLAP came out, we all had opinions on whether it was a good piece of technology or not. There's still a lot of opinions between dimensional modeling versus ensemble modeling. And even within ensemble or data vault, there's 101 opinions on different ways of doing things. And my view is opinions are great, but actually it'd be far more useful if everybody had a set of patterns that they referenced when we were having discussions. So I'm going to go through and talk a bit of history about where the idea of patterns came from, some background of where I've used them, and then bring up a couple of patterns that are related to Data Vault to give some examples and a bit of discussion around that. So the best definition I have for a pattern is this one, and for me, it's the three words that are in blue that are the key. It provides a good solution, so a solution that we know has worked before, to a problem that is recurring. So we see the problem time and time again, and therefore we craft a solution which is reusable. And the third one is that it provides a common language, that we are using the same words or looking at the same thing when we're talking about whether that pattern actually is a good solution for that particular problem. So where did the idea of patterns come from? Well, the earliest version I can find when I do the old Google search is this book that was produced in 1977, which I've got on the shelf behind me. And it was a book around patterns for building houses. So it goes through and it talks about where the house is going, the direction of the sunlight, and different patterns you can use depending on what the room in the house is, and where the light is, what type of weather you get. So it gives a practical language, again, coming back to those three terms that I highlighted on the previous slide, this idea that we have a language which is shared. The other thing it does is it breaks the pattern down into 4 bits. It actually describes the problem that the pattern's trying to solve. It provides an illustration that gives you a picture of what the pattern looks like, discusses the solution that that illustration gives you, and then discusses all the context around the problem and when that pattern could or could not be applied. And so again, the book was coming through and saying, recurrent design problems and a language that was created. So that's great for building, but where would we apply that in data and analytics? And for me, there's a website out there, Cloud Computing Patterns, that I found a couple of years ago. And what they do is they provide, it's based on a book, they provide a set of patterns for cloud infrastructure effectively. So the one we can see here is their definition of infrastructure as a service. Again, same concept or same flow as the building book, in that there's a name, description of the thing. There's the problem statement that they're trying to solve, some context, a visual solution with some words, and then linking through to related patterns. And so this is great. But what happens when you get a bunch of architects together discussing patterns? Well, whenever we get a bunch of architects together on anything, we tend to have an argument. And my observation is, while we're arguing, we're often agreeing. And by that, I mean, we often are arguing about different things. So I suppose it's the apples and oranges. We are arguing about a pattern for fruit, but one of us is arguing that, it needs to be orange, and one's arguing about red. For an apple, but actually it's not the important thing we need to argue about, and that semantics becomes one of the major problems. So what I found was, when you take those patterns and you put them side by side, we get a shared language. So I really like this scenario. This is back to a few years ago when cloud was still relatively new. And I remember from an enterprise architecture point of view, there were lots of arguments about what was infrastructure as a service versus platform as a service versus software as a service. And when you put these three pictures together, for me, it gives us a good story where the one on the left basically says it's the hardware, physical and virtual. Then if we go into PaaS, we get the operating system in the middleware that comes with it, and we're left to deal with the application and the business processes ourselves. And if we want SaaS, well, effectively we get everything out of the box. We're just dealing with our core business processes and how we implement them in those products. And for me, those visual comparisons are really, really important. It helps us agree when we disagree, but also agree when we agree and we're implementing something. So I want to look at the idea of patterns from a data vault perspective. But before I do that, I'll give you a little bit of background about where my thoughts and my comments are coming from. So many, many years ago, when I was much younger and much handsomer than I am now, I started up a typical data and analytics consulting company. So, the idea of 10 to 20 people who are consultants go out and engage with business, understand what their problems are, figure out how we can use data and analytics to solve it and implement that for them. And what I found was none of that work was repeatable. Every time we were reinventing the wheel, and I got frustrated. And my first attempt to solve that was to define a methodology and implement it. And the problem with that was that methodology became fixed. It wasn't a toolkit that we could use, it was a blueprint we had to follow. And that caused us a lot of problems. So in later life, I've done a lot of work around enterprise architecture. And what I found was the use of patterns allowed us to take the toolkit of ideas and apply them with the right context. And I've got an example at the moment. I'm working with an organization that's looking to buy and implement a new data platform. One of the things is they're looking to do it in the cloud. So for people based in New Zealand, the majority of our cloud services are actually hosted out of Australia. And we need to get the data back into New Zealand at some stage. But luckily enough, the enterprise architecture team at that organization had a pattern already for onshore data copies. So what that meant is as we define out the data and architecture, the data architecture and the platform architecture for this, we can just reuse that pattern of onshore data copy and we don't have to reinvent it ourselves. Same thing from one of the things I love to do is coach data and analytics teams how to apply agile ways of working to change what they do. And one of the problems we have is we'll start off with a small team. We'll start off with, say, a squad of 4 or 5 very skilled people as we build out the platform and start building out the data products. But over time, as we get more and more success, we want to scale. And so we might go to 2 squads or 4 squads or 8 squads. And if we're not using patterns that are well described and well implemented, then as we bring those other people on, we have to retrain them. We have to craft that shared language with them. And so we found that when those teams create patterns, the patterns help onboarding those other people. And the thing I'm doing at the moment is a software as a service product for data effectively called agiledata.io, and that's all based on patterns. My co-founder and Nigel and I have worked together off and on for many years. And so under the covers, everything we do is based on a pattern that we agree and can change in the future, but it's a pattern and that's effectively how we communicate. So let's have a look at a couple of examples. And these examples are my examples based on some of these experiences I've had. So rather than give you a page of very small text like this, which I'm actually created into a website to try and document these patterns, I'm going to use a comparison example like I did for infrastructure as a service. So this is the problem of if we want to centralize our data and we've defined using a data vault modeling technique is what we want to do, what patterns can we apply? And so the first pattern is the idea that we can take data from a source application, move it into the vault, and then create some kind of reporting layer or presentation layer to visualize it. And that's a fairly standard pattern. But there is an alternative pattern out there, which is we take the data from a source application and we move it into a persistent history. or persistent staging, and then we vault it on top of that data, and then we do the visualization. And when I was thinking about that, I came up with a third pattern, and in this case, we're replacing persistent history with data lake. I think the term everybody is saying is data lakehouse. Now, what was interesting about this was I passed these patterns past Michael Muller to get some feedback, and he asked me some really interesting questions that I hadn't thought about. So his first question was, well, is persistent history a source-specific data vault? And I said, well, no, because for me, using the vault modeling technique only is the top pattern. For me, persistent history is where we store the historical data in a single table, and we either upsert it and use windowing functions to find the current record, or we effectively indate it. And then the second thing he said is, why do you have data lake in there? And for me, it was like, well, I see the pattern that we use for deploying a data lake is slightly different than the one we do for a persistent history layer. Now, in the past, we might have said that the data lake was Hadoop, or we're storing everything in Parquet. But with things like Snowflake now, we can actually store the JSON objects in a relational database. So I can't say the difference between those two patterns of persistent history and data lake is the fact that it's in a relational database or it's not. But I think I can say that persistent history actually has schema on write, and a data lake has schema on read. And for me, those are two ways that we could differentiate these patterns. The other thing that this one provides is an interesting idea around compound patterns. So again, Michael, first thing, second and third thing he said to me was, oh, well, how do we deal with the visualization? Is that stars or is that denormalized? What is it? And that's the idea of a compound pattern, that each of the pattern nodes can actually have more detail underneath them. But for me, I think it's important that we try and keep the pattern simple at the beginning, because we're trying to agree on what we're going to do, and then we can drill into more detail. So the way we do the visualization layer will be very different, right? And these are vault-only patterns. If we talked about dimensional modeling, they could look the same, where we just replace data vault with stars, or they could look different. So another example, and hopefully a simpler one, is the idea of, if I've got source data that's based on header detail, or so the idea of I have orders and order lines, or invoice headers and invoice lines. How do I model that in the vault? And for me, this is a fairly simple one, but for some reason, it's the one that I always forget. So writing a pattern down and drawing the picture helps me remember when I come to actually do that modeling how I should do it. So we have 4 tables coming in from source: customers, our orders, our order lines, and our products. The pattern I tend to use is, we create a hub order line, a hub customer, and a hub product. And then we create 2 links, a customer and order link, and a order line product link. And that kind of works, or it works well. But I have an alternate pattern down there that's slightly different, where I've actually added the customer onto that second link. And why would I do that? Well, in our product, what we've done is we automatically create what we call consumable views, but presentation layer that's virtualized off the data vault model. So as soon as a link turns up, we denormalize that link out. We pick up all the hubs and all the SAT records and denormalize it into a view. And we do that because it means we get speed to market. As soon as we've created those hubs and SATs and links, we've got something that we can query. And interesting watching Peter's presentation earlier today, where he has a pattern that he doesn't allow people in his product to go in and query in the vault layer, only in the consumable layer. Same pattern we apply. So again, we have a shared pattern there, which is great. So for me, we would potentially use that second pattern down the bottom when it's our product, right? When we're figuring something in there. And that's fine, because we've made that decisions with the trade-offs that's required. So another one that's probably, or definitely, a contentious one. What do we do when we want to get a golden record? when we want a single view of customer or a single view of product or a single view of supplier. So the standard pattern is the idea of a combined hub. We have organizations sitting in our CRM and we have suppliers sitting in our financial system. We should take those keys and bring them into a hub. We should create a set from the CRM, a set off from finance, and then create a master or a golden record set using some rules. The trick with that one is we're relying on the source systems sharing the same keys and never having a key collision. And in my experience, that never really happens. In 30 years, I can't think of one customer that actually had all their core concept IDs syndicated or federated across all their source systems. As specifically, if you add Excel into the mix, you know it's not going to happen. So what are the other patterns we can do? Well, what we can do is we can bring those keys into the same hub, concatenate the key with a source identifier or identifier of some sort so we don't get any key collisions, and then write some logic and store the results of that logic in a cell, in a same as link, where we can now say that, you know, customer 1 in CRM is the same as customer ABC in finance. And that's fine. And then we've got the same sets to do it. There's a third pattern, which is one that I'm a great fan of, but not a lot of other people are, where I actually take the CRM organizations into their own ensemble, their own hubs and sets, FMIS across into their own hubs and sets. And then I use the same matching logic that we would use to create the cell and the, you know, conformed set. And I create another hub and another set. And why do I do that? Because it allows me to model iteratively. I can bring the CRM stuff in first, I can bring finance in second, and I can combine them when it has value. So effectively, I'm creating a source-specific vault, but I'm okay with that. You know, there's some downsides in terms of data duplication. There's some downsides in terms of which one is the record we should be querying. But remember, we take care of that in the consume layer. So we've moved that technical debt of being able to understand which one we should query off to the right-hand side with another pattern. So they're all trade-off decisions. But by providing these three patterns in a diagram, I can point and say that's the one that I do. And somebody else can say the top one's the one they do. And at least we're talking the same language rather than arguing across purposes. So the last one, thank you. The last one I was going to do is a relatively simple one again. So the idea of what do we do about reference data? So we've got data that's not, you know, being manually crafted. Perhaps it's a list of regions. Well, the standard pattern is take those regions and the standard pattern for me is take that file, bring it in and create an ensemble, create a hub and set, and then use it that way. An alternate pattern is just to bring it through as a reference table and not ensemble it. Why do I use the top one? Well, because in our product, we have a pattern for creating hubs and sets. So bringing that reference data in and putting it through the same rules engine is easier for us than having to write a whole lot of code to deal with these other objects. And again, as I said, we automatically create those consume views. So because the reference tables become hubs and sets, they're automatically presented to the users and their BI tools out of the box, versus we'd have to create a whole new pattern for creating those consume views if we retain them as tables. So, takeaways. Everybody has an opinion, but actually everybody should document their patterns and bring them to the table so we can argue we're using the same language. First takeaway for me. And the second one is actually putting the patterns side by side to give us a visual comparison actually really helps when we're having those discussions. So a bit like Roland, when he asked yesterday for people to look at using a shared metadata schema across all these automation tools, I've got a bit of an ask for everybody as well. I'd actually like your help, if you're willing, to help me build out and document some of these patterns using the pattern template. So if anybody's interested, there's my details. Get hold of me and we'll figure out, any way we can work together to make data a better way.